Hey, welcome to this third lecture on building or coding up your own Autograd system. Now, in the first two parts of this series, we had understood how a computational tree or a computational graph can be built, right? Based on the basics we covered in the first video, right? Which was on chain rule. Now, in this video, we're going to start implementing the Autograd system from scratch. So let's get coding. Let's now start implementing the Autograd system from scratch. So the first thing we need to do with Autograd is to implement a custom variable, right? And then that will form the basis of the entire Autograd system. So let's go. We're going to call this variable scalar, right? And so what we're going to do is define a class called scalar. And what this class for now takes in is a value, right? So when you initialize it, give it a value, and the value is stored. And that's kind of all to start with, right? And so let's say I'm going to define a variable a, and I'm going to say a is scalar, and I'm going to say point, right? And it's that I have to define scalar and start with that. Now, what's the first functionality we want to implement? So what we're going to do is overload some of the existing functionality now, right? Of a typical object or class, and that will help us now add functionality. The first function we're going to set up is the repr function. Right? So we're going to say, and what this allows us to do, right, is if you say print and say a here, for example, you can now print it in a custom fashion, right? Right now, if you say print a, you get this kind of object print format. Instead, we're going to say for print, and I'm going to use an h string, and I'm going to say, well, what I needed to print is just self dot value. So if I use the basis, and I say self dot value, right? Let's rerun this, and then we've got that. So we've overloaded the print function, and now this scalar class we've created, to create an object with that, it will print in an interesting format. Now, what do we want? We want a system where we can now say this. Let's say a separate variable b. So let's say you have b is scalar 1.0, right? And then I want c is a plus b. So I want to implement the addition operation for this. Now, if it was a typical number, so if you do 2 plus 1, you should get 3. Can this do that? So what we're going to do for that is overload the addition operator. How do you do that in Python? You say def underscore add, right? And say self, and you want to pass in a value. I'm going to call it other. So what this will do now is if you say a plus b, if a and b are of type scalar, then it's going to look in class scalar and see if you've defined this add. And if you have, it's going to use that. So what is the addition operation? It's quite simple. I'm going to say first, I'm going to assume you're going to pass in something that's also scalar for now. And if not, we want to add a check to that. So we're going to say if is instance, right? And if you're saying is instance, you're saying other is of type scalar. Then what do? You say sum is self dot value plus other dot value, right? Now what I'm going to do is define a new variable called sum. So let's call it out actually. And I'm going to say is scalar, and the value it takes is sum. And I'm going to return. And if the instance is not of type scalar, then I'm going to say return an error. Right? So we're going to say actually, let's raise an error. So we're going to raise a type error. And we're going to say invalid for of two scalars. Simple. So with that, we should have addition. So if I say C is A plus B, and then I say print C, what do we get? And actually, I'm just going to say C and C, and this is A. Right? And we're also going to print B. And so it's actually not that. And so C is 2 plus 1 is 3. And it's using C is of type scalar, right? And it's using the overloaded print order. Let's define one more operation. So we're going to keep it simple. We're going to use the multiplication operation. And in this case, we're going to, for now, keep this class to be one that only uses that only is defined for mathematical operations associated with the scalar object. So if you, for example, say C is A plus 2, it's not going to work for now, right? Okay. So let's say multiply, and so it's mul. If you say def mul, it's going to overload the multiplication operator. Now, if instance other is scalar, and so this is not sum, this is product, is self dot value times other dot value. Out is scalar product. And if it doesn't work, and it's invalid operand, not operand, it's invalid. You say for multiplication of two scalar. So simple. We run this, and now let's just say D is 4.0, or rather scalar 4.0. And then let's say E is C times T. And let's try and print. And it's going to say unsupported operand of type. No, that's interesting because I've defined the multiplication, but that's because I haven't rerun this. Because I had to recreate or rerun C again so that would reflect the change in the class. And so we've got 4 times 3 is 20. So what have we got here? We've got a simple variable or custom variable called scalar, which we've created. And it's not a variable, actually, it's our class. So we've created a custom class called scalar, which now we are going to use as a variable. And we have seen that we have defined both the print, the addition, and the multiplication operation. Let's do one more small thing. We're going to say self.label is equal to this. And I'm going to add an argument you can pass in when you set this up, which is label. Right? And when we print it, we're going to say self.label. And that, right? And what I'm going to do here is say label is equal to A. I'm going to say here label is equal to B. Now for C, I'm just going to say C dot label is equal to C. And then for D, I'm going to add the label here. So I'm going to say D, and I'm going to say E dot label is equal to E. Let's rerun this. So let's set this up, rerun this. And now we've got that, right? So actually now we don't even need the A and all that. We can just take that out. Because when you print it, it's actually going to print with the label, right? I need to move this above for that to be reflected. So if I move this here, and then it's the same thing here. And let's also just add a space here so that that's reflected. And so let's rerun that, and you have that, right? Now have I? So okay. So when you say self.label, you have to take in the and got that. So we've created this simple class called scalar. We're now going to, and we can do basic multiplication and addition as well as basic printing with this. What's the next step? The next step now, we're doing operations, Let's now see if you can modify this so that it stores what we call the parents, right? Or the operands for an operation. So for example, C, as of now, you get C is A plus B, you get the value, but C as of now doesn't know how it was created, right? Doesn't know that A and B were there. So let's next modify this so that C now knows that it was created from A and B using A and B. And then we'll use that information to allow us to construct or build a computational graph to start, right? So that's the next step in this process.